examples or exercises. What do you know about perpendicular lines? Guys, so what can we deduct if we know that lines are perpendicular? You can share your answer in our chat box. So we have line AC, which is perpendicular to BD. So before we even solve our problem, what do we know from that statement? Okay, so so if we have perpendicular line, okay, already they showed us that they meet at a 90-degree angle, but then we also mentioned something about the gradient. Okay, so if AC is perpendicular to BD at point T, so we know that the gradient, so we can say the gradient of AC multiplied by the gradient of BD will be equal to -1. So thank you for your answer, guys. So yes, if we multiply the gradients of AC and BD, we will get -1 because it is given that they are perpendicular. Okay. So if you continue reading our statement, it says the equation of BTD. So we have BTD is 2y plus x equals to 15. Okay, so we are given an equation of a line. Let's also highlight that. So I given the equation of BTD and it's in that form. Okay, and we are also given that AB equals to 15 units. So if AB is 15 units, it means we know, so the 15 units is what? So the 15 units is the length. Okay. So the 15 units is the length or the distance. Okay, so we also have the length of AB. Okay. So then, now that we know what we are given, we can just go through the question to see what we need to do. Okay. In the first question, they say, determine the gradient. Remember I said sometimes the gradient, like in the question, they can say slope. Okay. So don't be confused by that. Gradient is also the slope. So in this case, they're saying determine the gradient of line AC. Okay. So from our knowledge, we know that, okay, to calculate the gradient of a line, we need change in y over change in x. Okay, so to calculate the gradient of a line, in this case, it's AC, okay? So to calculate the gradient between any points, so in our case, we can replace that. So this, in our case, is AC, isn't it? So we know to calculate the gradient, we need 2 points, but we don't know the coordinates of C. So we don't know the coordinates of C. Okay, but then we are given that AC is perpendicular to BD, and we know the product of their gradients. So what if you only have 1 point and you have that, how would you get the value? How would you get the gradient of AC? So how would you calculate the gradient, guys, if you only have 1 point? Just look at the statement and what we are given and try. So what information can we use to find the gradient? Okay, so we are given the line BD, which is perpendicular to AC. So we don't really need to know this point to calculate the gradient. Why? We are given an equation, and if we write our equation in terms of so if we write our equation in terms of y equals to mx plus c, do you remember? So if we write, so in this equation, if we write it in the form y equals to mx plus c, we can actually find the gradient of BD. Can you see that? And we can relate the gradient of BD and that of AC by saying the product of their gradients is -1. Okay, so in our case, if we solve for y, what would we get? If we solve for y in this equation, what would be the equation? So if we were to solve for y, what would be this equation? Please try. Okay, so what you will realize is that, okay, since you're solving for y, you will have to move your x to the other side of the equation, okay? So we would have 2y, which is equals to -x, because we want to write it in this form so that we can identify our gradient. So it would be -x plus 18. Okay, so we would get negative x plus 18, but then we want to solve for y. It means we divide everything, the left-hand side and the right-hand side by 2. Okay, so we will remain with y equals to negative half x plus 18 divided by 2. Can you see that? So by solving for y in our equation, we actually get the gradient. So the gradient of BD is equals to negative half. So do you guys understand? So we solved for y to write it in the form y equals to mx plus c, so that we can identify our gradient of BD, because we know the relationship between the gradient of AC and BD. Okay, so now that you know, so this is BD. Okay, so now that you know the gradient of BD, you only have one unknown, which is AC. Okay, so what would be the gradient of AC? Which number would you multiply with half to get negative 1? Guys, so which number would you multiply with negative half to get 1? Okay, so you will see that your gradient, thank you. So the gradient of AC is actually what? Okay, so even if you don't have 2 points, but you have another relationship that's given, then you can actually calculate your gradient. So it's not only from using this equation, there's other forms of finding your gradient. Okay, thanks for trying. So do you guys understand? Can we move to 3.2, or do you still need an explanation with what we did here? Okay, so 3.2, you are required to determine the equation. So you have to determine the equation of AC and write in the form y equals to mx plus c. Okay, so for line AC, you still have 1 point, but then another good thing is that you have what? You have your so another good thing about this is that you have so you're given a point, but then you also have a gradient. And according to this equation, okay, so according to this equation, if you want to find the equation of a line, you just need 1 point and a gradient. Okay, so in point AC, we do have a gradient, which we just calculated. So we do have a gradient of 2, and we have a point where that we can substitute in our equation. Okay, so to find our equation, remember, this is -2. So in the place of x1, you'll replace with -2. So please don't make that mistake, okay? So make sure that you have your equation correctly. So it means you will have y. So can you just try it? So you'll have y minus, I always use brackets so that I don't miss. So this is my x value, and this is my corresponding y value. Okay. So our y value is -5. And we have a gradient of 2. Okay, so we have a gradient of 2, and we have x minus another bracket -2. Okay, so always use brackets so that you can have the right values, because you still have to multiply your negative with your negative, which will give you a positive. And also in this case, you have to multiply your negative with your positive. Negative times negative, which will give you a positive. Okay, so in that case, you would have, so you would have y plus 5, which is equals to 2 into x plus 2. Can you see that? So if you didn't write your value correctly, then you would have lost marks for that. Okay. So now that you have your equation, but then they say you should write it in terms of y equals to mx plus c. So it means, firstly, you need to multiply your 2 with your x, your 2 with the other 2, and then you solve for y. So what do you guys think is going to be the answer? So try it. Because if you were to solve for x, let's use a different color. So in this case, if you were to solve for x, you would have, yes, great. So you would have y, which is equals to your -5. You guys are doing great. So you would have your -5 plus 2x plus 4. Okay, so you would have y equals to 2x, and looking at your like terms, then you would have -1. So now you have your equation. So remember that you should write your equation in terms of y equals to mx plus c. But what's interesting in this equation is that you were actually given, which is what happens in most papers. So you were actually given, can you see that? You were actually given the answer for AC in your equation. So it means even if you couldn't do 3.1 and 3.2, maybe you forgot how to calculate the gradient and the equation, then you would still be able to get the 3 marks for 3.3. Okay, so if you forget something, don't just give up. Just look into the questions and see if you can deduct something and then continue. Because with some questions, they'll give you an answer and then you just continue from there. Okay. So in the third case, you're given that, okay, if the equation of AC is that, now you have to calculate the coordinates of T. Okay, so you're given the equation of AC okay, and you are required to calculate the coordinates of T. Okay, so what do you think you need to do? And remember, there's more than one way of solving a problem. Okay. So you're given the equation and you're supposed to calculate the point, the point T. So what do you think you would need to do? Okay, so just to show you, ooh, okay. So just to give you an idea of how many marks you would get. So for the first question, okay. So for the first question, because you got 2 marks, you were given a mark for solving for y, and then also for getting the gradient, okay? And then for the second question, you were given a mark for substituting correctly. That's why I said you need to know how to substitute correctly, because if you had substituted -5 and then not multiplied it with the other -5, then you wouldn't have gotten your answer correctly. Okay, so please make sure that you substitute correctly. Okay, so if you look at number, okay, let's go back to our question. If you look at point T, what other information are you given? Remember, you just calculated. Now you have the length, the equation for AC, and you also have the equation of BD. And what is this point T? It's a point of intersection. Okay, so you have BD interacting with AC. So where 2 lines cross, you can say what they're equal. Okay, so you can say the equation that you substituted here for BD, you equate it to the one for AC, and you solve for X. Okay, and then after solving for X, you substitute your value of X in either the equation of BD or the equation of AC to get your value of Y. Do you guys understand? Okay, let me try to draw this again. So we have the equation of AC. Let's do it. So we have the equation of AC, and we also have the equation of BD. Okay, so at this point, so the different color. So at point T, it's a point where line AC, let's try to draw that. So this is our line AC. And our line B, T, D, K. Can you see that? So point T is the point where the line BD intersects, or it's crossing line AC. Okay, and from this equation, we said Y equals to negative half plus 9. Do you remember? So if we have the equation of BD and we also have the equation of AC, okay, which is this one. So at this point, we can equate them. Remember the point of intersection. Let's go through these quickly. Okay, Daisy.
Yes, ma'am.
Yes, so at point T, we have the line BD crossing the line AC. Can you see that?
Yes.
Yeah, so at the point of intersection, or where lines cross, you can say their equations are equal. Because,
Okay.
yes, you still remember that. So it's a point of intersection. So we're going to equate the equation of BD and AC and solve for X, because we'll only have one unknown. Okay.
Okay, ma'am. Thanks.
Okay, great. You're welcome. So we're going to have so there's an X here. And then we also have the equation Y equals to 2X minus 1. Okay, so at point T, we will have negative half X plus 9 being equal to 2X minus 1. Okay, so we can actually solve for X. Can you see that? So we can solve for X in our equation. So we will group the like terms. In this case, we'll have 2X minus, so 2X, when this term goes to the other side, it will be plus half X. Okay, then this would be equal to, so this term went to join our 2X, then the 1 will join the 9. So we'll have that being equal to 9 plus 1. Okay. And then you solve for x. Is that fine? So when you solve for x, you will have the x coordinate at point T. And when you have the x coordinate at point T, then you can easily substitute your value of x in either one of these equations. So if you solve for your x, then you can substitute your value of x into one of these equations, and then you get your value of y. So what do you think is the value of x? We have 2x plus half x, which is equals to 9 plus 1. So how would we solve for our x? So how would we solve our x? We have 2x plus half x. Remember, 2x is actually 2 over 1. Okay. So for someone who doesn't understand, we would actually have 2x. Oh, my bad. So this would be, okay. So this would be 4x plus x divided by 2, which is equals to 10. Okay. This 10 is 10 over 1. Okay. So if you add this, you will actually have 5 over 2. Just revise how to add fractions. So 5 over 2x, which is equals to 10. Okay. And then you would have, so whichever method you use, I would cross multiply. Then I would have 5x equals to 20. Okay, so I would have 5x equals to 20. And then if I divide by 5 both sides, then I would have my x equals to 4. Okay. Are you guys fine up to this point? So it's just that your point T is a point of intersection, and you can equate your equation of BC and AC because it's a common point, and then you solve for x because that's your only unknown. And then after you solve for x, you can use either this equation or the second one to find your value of y. Okay, but you will still get the same answer. Because if, for example, you use y equals to negative half multiplied by 4 plus 9. So you would get what? Negative 2 plus 9. And this would be 7. So even if you use the second equation where you have y equals to 2x, so you still have 2 times 4 and that minus 1, which is equals to 8 minus 1, which is 7. Okay. So are you guys fine? So the only tricky part was to see that this is a point of intersection. Okay, so I'm just gonna give you an overview of how you should try number 3.4, and then you can try that and then we'll do it together. So in 1.4, they're saying if your ABCD, so if ABCD is a kite, so it means you need to know so your ABCD is a kite. So this is your answer. You have a kite. Okay, so it means you need to know your properties of a kite. Okay, so you need to know the properties of a kite. And then in this case, they're saying if ABCD is a kite with AB equals to AC. Okay, so they're saying you have AB, which is equals to AC. Okay, and then you need to determine the coordinates of C. Okay, so the kite in this case is the hint on how you're gonna get your answer. Okay, because remember, okay, now we have point A, we have point T that we just calculated. So we have coordinates of T that we just calculated, and then now we need to determine the coordinates of point C. Okay, so if this is a kite and these are equal, so if you look at the properties I gave you, so if you look at a kite, then now they're saying these two are equal. There's a relationship in this line. So what you will see is that these AT and TC are all equal. So you would have 1, 2, 3. Okay. So now you have AC, which is equals to that. So if you have point A and C, how would you get point C? So you have coordinates of A, you have coordinates of T, you don't know your coordinates for C, but then you're given that AT and TC have the same length. So how would you get the point C? From using the properties of kite. So if AT is equals to AC, it means our point T is what? It's our midpoint, isn't it? So if AT equals to our our TC, then this is a midpoint of line AC, okay? So you can use that to determine your point C. Remember how we used the midpoint formula to get another point. So that's what you're gonna do, okay? So try that. And then you also have to, yes, thank you. We use our midpoint formula to get our point C. So try that. And also, let's quickly look at BT, point BT. Okay, so there's another equation that we can use. Remember, we can use the distance formula to find the length between 2 points, but there's another formula that we can use to find the length. Because if you look at this triangle ABT, it's a right angle triangle. So if you have a right angle triangle and you want to determine the length of a side, what do we use? We use theorem of Pythagoras. Okay, so guys, just go and try that, and then tomorrow we'll finish off number 3.4. Okay, and if you still have questions, you can send me an email. So tomorrow we will continue with this question, and also please try to attempt the 2018 question paper. Okay, great. So we will continue tomorrow, and just try number 3.41 up to 3.43. Okay. And then try the 2018 question paper and send me an email.